So welcome to question number 4 from the Edma 414 midterm paper. And as I said, this series is a review of the ten questions that was on the test on November 19, 2021. So question number 4, we were told to prove that a sin x plus b cos x all square plus a cos x minus b sin x all square is equals to a square plus b square. So to do this proof, we are going to take the left hand side and simplify the result till we get a square plus b square. If we simplify the right hand side and do not get a square plus b square, it means that these two are not equal. But we are told that these two are equal for any value of a and b. So let's see what happens. We begin with this side. So a sin x plus b cos x all square. We are going to use the expression in algebra that says that if you have a plus b all square, the result is actually going to be a square plus 2ab plus b square. So we're going to use both. We're going to use this for both of these. So let's use this for the first one. So in this case, our a is a sin x and our b is b cos x. So it was quite the first thing we have a sin x all square plus 2ab. So that's 2 times the first expression is a sin x, and the second expression there is b cos x. So that's b cos x plus b square. So the last term square. So it's b cos x all square. And this is the expansion of this. This is the expansion of this. Plus, let's look at this. We have the first term square, a cos x all square. Now, plus 2ab. So that's plus 2 times a is a cos x. And then this is negative b sin x. And then last term square. So we have plus, the last term is negative b sin x all square. And notice that when we expand this entire thing and simplify, we should actually have a square plus b square. So if we do this, a sin x all square will give us a square sin square x plus, and this is going to give us 2ab sin x cos x. So we multiply a times b, and then we multiply the result by 2, and then we have sin x cos x. And then we have plus b square cos square x plus, this is going to give us a square, this cos square x plus. Now 2 times a is 2a, 2a times negative b is minus 2ab sin x cos x. Remember there is a product, so sin x cos x is the same as cos x sin x. Now plus, we square negative b sin x, and we are actually going to have b square sin square x. Great. Once we do that, we can collect leg terms with the same form. So we have 2ab sin x cos x, negative 2ab sin x cos x. So this and this are going to cancel out because they are the same expression, they have different sign. So we'll be left with a square sin square x plus b square cos square x plus a square cos square x plus b square sin square x. Good. After that, we are going to collect all of the term with sin square and all of the term with cos square. So what are those things that have sin square? This and this. So we have a square sin square x plus b square sin square x. This is how we have plus, and then we'll move on and collect b square cos square x plus a square cos square x. And once we do that, we have to factor out a sin square from the first two expressions there. So if we factor out a sin square, we have sin square will be out, so that's sin square x, parenthesis open, this will be a square plus b square. Because this time these two is going to give us this. Plus, if we have factor out a cos square, so we have cos square x, parenthesis open, this is b square plus a square. which is the same as a squared plus b squared. Now, when you see something like this, it reminds you of what we have when we are doing factoring by grouping. So we are doing factoring by grouping. You always have the coefficients of the expressions being the same here. So this and this are the same with different coefficients. And the rule says we group the coefficient and take one of the two expressions here. So we have sine square x plus cos square x in one parenthesis. And then we have a square plus b square in another parenthesis. But this expression sine square x plus cos square x resembles something that we know from the Pythagoras theorem for trigonometry. We have, so remember that sine square x plus cos square x is actually 1. So this entire expression is 1. So we have 1 times a square plus b square, and 1 times this is actually a square plus b square. Therefore, the right hand side or the left hand side is this entire expression is equals to the left hand side, which is a square plus b square. So the right hand side is equal to the left hand side, and we have proven that this is equal to this. Thank you very much for watching, and we hope to see you in future installments of our videos.